Hello everyone, welcome to data structure video tutorial. This is the third video. In the last two videos, I have explained initially introduction to data structure and what is the importance of data structure, later the classification of data structures, then operations of data structures. Okay. In today video, I am going to explain what is a union and a structure. Then we will move to pointers and self-referential structures. Just have a glance. These are things we covered. Okay. Uh, Here comes. Structure is an user-defined data structure. Okay. Uh, User-defined means user can create his own data structure. Okay, with the keyword struct at the beginning. What is the difference between array and structure is that in the array we can store a homogeneous set of elements, or you can say same set of data types we can store. But in the structure we are going to store elements of different data type. That is a structure in a single variable name. That because of this reason we can say structure can be used to represent a record. For example, we can make use of storing the records of a student, or you can make use of storing the record of an employee. Then we can consider a library. So these all things are example for the structure definitions. Okay, so in this defining a structure nothing but we must make use of struct as a keyword or statement to define the variable which I'm going to refer as a record. So if I consider I'm going to maintain the book record, then I have to specify struct with the name book. The user defined data structure contain two words here. We must make use of both the words. Initially you must specify the struct, then you have to specify the name, structure name. So here struct will be a keyword, then structure tag. If I am referring the books detail, then I specify books here. Then inside that different fields of that record will be mentioned. Like book contain a title. The title contain it is an character type. So that character title. Then it contain author. Author also it is an alphabetical values, so that you will make use of character author. Then we can make use of subject. So character subject is the letters only, so that we make use of the character. Then book id will be in terms of number, we make use of the integer here. So the structure is the collection of different data types. It may be character, it may be integer, it may be float. So it can store all the elements of different data types in a single variable. So single variable is books, which holds all different data types. Then what is the advantages of structure is that here I can access all the elements which are stored in the variable at a same time. I can process them parallelly. Like if I allocate the memory, so we can take an example here. Character holds 1 byte of memory, so I am specifying 50, so that 50 bytes will be allocated for the first variable. Similarly 50 bytes will be allocated for the author, whereas 100 bytes will be allocated for the subject. For the book id I am not mentioned any value, so that it refers only 2 bytes of data. So whenever we are going to store the values inside memory, always some basic address will be there. Here I have taken example of basic address is 2047. So title carries 50 bytes of memory, so I am allocating 50 bytes here. Then similarly for author 50 bytes of memory. Then similar subject is 100 bytes of memory. Whereas id it carries only 2 bytes, so that I am allocating 2 bytes of memory. Okay, then it is of how to define and declare the variable. Next step is that how to access the elements of a record uh, will be done by making use of and dot operator. Okay, so accessing the structure members are based on the dot operator. I want to, for example, I want to access the title of the book which I referred here. So in order to access this one, I have to specify struct and the structure name. Then I'm specifying the new name. Okay. So whenever I'm going to access element from the structure name, I have to specify the new name. So that will keep track of the values one after the other. So if you want to access title, you have to specify book1 dot title. If you want to access the author, you can make use of book1 dot author, like that. Similarly, I have to make use of another uh, same books variable can be referred with the another variable book2. So you can access second time with the second variable name. And initially I'm going to it is the first bit is the character type, so that I should make use of string copy. So title will be copied to the book title, that is C programming. Okay, similarly I can make use of book1 dot author will be fetched. And then subject, again it is the character that will be copied, but id will be an integer, so directly I'm assigning the values here. Okay, this is for accessing the data. If you want to print it, then again just make use of book1 dot title, book1 dot author, then subject with the printf statement. So these three are string values, so make use of percentage s. Then for the id it is integer, to specify percentage d. So same will be applied for the book2 also. Then next is a union. So union is another user defined data structure. Difference between structure and union is that in the structure, number of members is equal to the number of memory allocated. For example, in the previous example, there are three members are there. For all three members separately, the memory will be allocated. But in the union, out of those three, whichever the variable carries maximum weight, maximum memory, that memory will be allocated. The remaining variable has to share that memory. That's why it said you can define union with many member, but only one member can contain value at any given time. So in the structure, you can access the all three variable at a time. Okay. For example, if I mentioned three different data types inside the structure, all can be accessed at the same time. But in the union, the memory will be shared among all the variable. That is why we can't access them at the same time. You have to access it separately, one after the other. So I have given an example uh, in this. Here integer I, float f, character string of 20. So integer I contain 2 bytes of memory, float f contain 4 bytes of memory, whereas character string of 20. So that character was single byte into 20, so that 20 bytes will be allocated for this string. Out of these three, that is, it is 2 byte, it is 4 byte, it is 20 byte. Among all three, 20 byte will be the maximum, so that I'm going to assign only 20 bytes of memory for entire union. So that is why when one variable is accessing the memory, other has to wait. We can't access them at same time. So I have given as an example here. So if and str, that is integer, floating point and string, all will carries only one allocated memory, that is whichever is maximum. Out of these three, maximum is character, so it holds 20 bytes of memory. Remaining these two variable have to access from this memory only. Okay, and accessing the data remains same as that of structure. We have to access them by making use of and dot operator. If you want to access the integer I, then here are defined union with the variable name with a new variable to access individual bit. So data dot I am assigning the value here 10. then data.f, I'm assigned the value 220.f file. Then if you want to print them, just print by making use of the percentage d. Okay, then if it is string is there, then you have to copy that one. Then the next bit is a pointer. Pointer is an very important bit for accessing the dynamic memory allocated values. Okay, so why pointers are required means they are accessing the data in terms of addresses, not in terms of memory location directly. Like in the arrays and integer, we can directly access the values from the positions where it is stored. But now we have to make use of address. By using address, we have to fetch the data. Okay, that is why we require an ampersand symbol. So access the data by making use of an address. Ampersand indicates an address. Here I have given one example, integer variable 1. So variable 1 holds 2 bytes of memory, and if you want to get address of it, I have to specify ampersand variable 1. So it will fetch the address where it is stored. Similarly, variable 2, it will define the address where it is stored. Then what are pointers? Pointers which holds the address of another variable. Direct address of the memory location. So I'm not accessing data from the memory location, but I'm accessing data from the addresses. Okay, and the syntax will be type star variable name. Variable name defining the same as that of how you are defining the regular variables. You have to follow some rules. Then star is for just like it represent an address. Then these are the example like how to declare the variable. Then how to use the pointer. There are three ways we can there are three steps to represent the pointer. That is, first define the pointer variable, then assign some address of variable to pointer, then finally access it. So with an example, here initially we assign it is an pointer variable, we assign some address of the variable. So already I declared one variable initially, so I'm going to assign this address to the pointer variable. Okay, these are the steps. So initially a variable will be declared here that contain variable with 20 value, that contain some memory address. Then that memory address will pointed to where the IP variable. So address of variable and this IP ampersand variable and IP contain same answer. Like here ampersand variable, if I display ampersand variable and if I display IP, that we get the same answer because IP holds the address of the variable. Okay, then the pointer star IP means we have to access the value where 20 is stored by making use of the address. So star IP is specific, go to this address. With this address the 20 value will be stored, that will be displayed. Okay, so these are the steps how we access the pointer. Then self-referential structure, nothing but a structure referring another structure of same type. So we can have the example of linked list, stack are the main example for self-referential structure. A linked list supported to be a self-referential data structure because the next node of the node is being the pointed. So whenever you want to fetch the next node of the linked list, that time it has to contain the address of the next node, and both are of the same type. Okay, so here I give an example, type def struct the list node. So this struct list node star next will contain the same structure that referring itself. While solving the examples on linked list, you're going to uh, will find the exact representation of self-referential structure. Okay, for time being, just you should know what is the syntax of it. That's it. And go through this video. In the next interaction class, I am going to solve the queries among regarding this union structure, pointers and self-referential structure. Just go through it. Okay, and practice the simple example. um, so that you can able to solve complex program or lab programs in the lab session.